Whoop, whoop. Whoop, whoop. Another fun night on the Grapevine Show. All right, introductions, because we missed last week. I'm going to blame it all on Mike. Mike's out changing capacitors left and right. Dude,
Capacitor
what's
bandit.
are you catching any of that hurricane damage repair work? Are you doing any of that? Are
No,
you
not
is your
West
area
Coast.
super affected? Okay, it's a West Coast thing.
Yeah, we did get
Interesting.
we got like something like 75 tornadoes though. That was bad, bro.
Yeah, it was
So
great.
there
I
was
heard there was like 150 something or some
Yeah.
crazy number. Like,
yeah, it's Florida. You know, like has
Yeah.
it ever happened before?
Yeah.
No, it's Florida.
That's pretty interesting. I'm because I've been to quite a few hurricanes, but I don't ever remember spinning. I mean, there might be like one or two tornadoes
One
that
or
spin
two,
off of a
yeah.
hurricane. Never heard of it being
Yeah.
like like 100 tornadoes that comes out of
I'm
barreling out
getting
of
a
that
little
thing.
bit of a complex, bro. All of us go to NCI. We go to the summit. We go to Asheville. There's a hurricane in Louisiana. I'm like, oh boy, I got to get out of Asheville. Asheville don't do so good. I come back home. There's a hurricane, tornadoes. I'm like, I don't know. I'm getting a complex, bro.
Yeah, you're bad luck.
just
Sounds like
leaving, man. It's following you, I think.
That's
is
what
Yeah.
I'm saying.
hearing
I'm
from
starting to
that.
get a complex, Mike. And by the way, thank you for letting me share a room with you, Mike.
Yep.
You're the man. Holy smokes, man. Asheville was a blast.
Yeah, that was fun.
Yeah.
Can't wait to
That
do
was
something
good.
like that.
Dude, we
again.
had some good live streams, bro. That was a blast.
I mean, I just want to say it, man. Like I just want to like catch up with the boys again somewhere. Like when's the next happening? Like where are we going?
Symposium.
Is it? Yeah, I think it is.
It's coming.
Symposium's going to be
soon,
next.
right?
I'm ready for that one.
October,
fun.
baby.
Yeah.
Yeah, what are
meeting
we
of the
looking at?
mind.
January?
Yeah, I think so. Isn't it? Is it
Oh,
January or early February?
It's end of January, early February, some in
Yeah,
that
it's right
time
there.
frame.
Yeah.
Yeah.
Got to get through these
AH on that
holidays,
day.
man.
Yeah, man. I'm already buying stuff for the little ones on Amazon.
Black Friday's like just getting earlier, it seems like.
Mhm.
Yeah. Word. All right, man. So I'm going to jump into tonight's topic, which is hydronics. And Mike, I know you're like a hydronics expert. Is it fair to say you're a hydronics expert? I mean, you're probably.
I
Go
don't
ahead.
look at myself as an expert in anything, although some people call me that at things. So,
Yeah. Well, you know more than me, that's for sure. Especially in hydronics and probably a little bit of everything else. But
He's just an overall badass at everything. We're just going to scoot it with that. Yeah. We'll stick it to that.
hydronics, hydronics is something I find very interesting, but I don't know many people I don't know many people very well who know hydronics very well. You're like my hydronics guy, Mike, when I have a question. Which I've
it's
actually
not super common in the South, really, right? As much as it is up north, and even in my area, I feel like it's not super common compared to, say, the Northeast of the country.
Oh, really?
New York and Maine and all of that stuff, and so
it's
That's right. Jennifer says there's a lot up by her in Maine, right?
yeah.
HVAC
Yeah.
Jennifer.
it's common, but it's common in a different way. And what I mean by that is like, of course, you could kind of say hydronics is commercial air conditioning, right? When you have chill water, like there's plenty of that here. There's plenty of that kind of everywhere. Hot water, things like that. And that's where my hydronics experience lies, is in that arena. But residentially, hydronics is here, but it's very small, right? It's just a small pocketed area that has like hydronics. And I don't even know why that is. It just is that way. I think it's because the area I'm talking about, a lot of people are on well water. And maybe
okay.
that had something to do with the decision making behind
Something
to go with
like
hydronics.
Katrina, there was a lot of people from Louisiana that go up to Maine, and then they come from Maine, they go back to Louisiana and bring hydronics down. I think
Would be a
we just
problem.
cracked the case,
Probably what
bro.
it is.
That Louisiana
Like
Maine
one of the
connection.
hurricanes brought it way back
Yeah, there
then.
you go. So what I'd like to do, Housh, is take a step back and because I'll tell you what I don't know about hydronics. I don't really know anything from the design side. I may have put my hands on a lot of like commercial chill water systems, but how to think about like how to set up hydronics at a home, I wouldn't even know where to start. I mean,
Well, it's
okay,
like
I get a heat
air, you
load,
got to start with the load, right?
right?
Okay.
So I would love to hear your spiel of um, it would be fun on an existing home, but a new construction home might be easier to explain. But take us from the point of getting a load, and then where do you go? How do you go from start to finish doing hydronics?
Well, you would then, in my opinion, you would want to know like what is your distribution source, right? Like, so are you doing hydronic air handlers? Are you doing radiant infloor? Are you doing baseboard radiators or a mixture of those?
Right.
Because
Okay.
that dictates the water temperature that you're choosing
Oh.
for the different components and
Because
elements.
I remember when I was younger, we
Now
had
you got
those
me super
cast iron.
curious.
You're bringing me back, bro. I remember the cast iron. We call them radiators.
Yeah, radiators. But
Radiators. You know, those New Yorkers are just like all over with the lingo, bro. And then we moved
Radiators.
radiators, and then I remember we moved into a new house, and then they did the baseboard once. So we upgraded to, and it went along the whole wall, which was similar, right? That's same concept, right?
well, sort of, but the big cast iron radiator has a lot more mass to it, right? And
Right.
so they can, you can get different BTU outputs depending on what water temperature you give to
Right.
all of these devices, right? And so baseboard radiators often require
Like longer
a
runtime.
higher water temperature because the element is smaller. It's just like a copper tube with fins
tube.
on it. And so you can run into challenges if you're trying to use a condensing boiler or try to get the highest efficiency boiler, but you are stuck with something that doesn't have a lot of mass to it, like a baseboard radiator.
Okay. Yeah, I
Man,
remember
this is
putting the boots up after coming out of the snow, throw them right on that old radiator, whatever the hell it is. It was
so. Man, I got so many questions after just that first part that my mind just like exploded, and I started thinking about the variables and the complexity of this.
yeah,
I could understand the air handler, right? Like that's kind of easy to understand if you're in HVAC. You have an air handler, it blows air. There's a specific amount of heat temperature, right? Like we play that game kind of every day, right? There's that understanding.
Yeah,
I think
and the nice thing, just to stop you there for a second, one of the good things about hydronics is they have this thing called outdoor reset, which is sort of common. And so with an air handler or something like that, it's somewhat easy to choose. What that means is when at a given outdoor temperature, what is your water temperature going to your coil, right? And so you're able to match the load better in a lot of scenarios by using outdoor reset. So generally you pick a temperature at your design, your say, 140 degree water temperature, but when it's 50 degrees outside, you only need 100-degree water temperature,
wow.
right? And
so that just complicated it even more for me. Can we
well,
back up though?
it's
Can we back
essentially
up
like
more?
a
Where does it
variable
normally come
speed
from?
unit almost, right?
Yeah, right,
so,
right. But where does it normally come from in your area? Because I remember back home, I didn't get into any of this. I moved when I was younger down here. Are we talking boilers? Like we had oil and gas where I was from. So oil burner, is it? Let's start there.
I mean, there's all different flavors. You know what I mean? Like, so there you get
like an ice cream,
boilers. You have oil boilers.
Okay.
So
You could use like a regular
I've
water
never,
heater.
I've never seen an oil boiler in my life. I've seen plenty of gas boilers, plenty of big,
Yeah, I
large
mean,
gas boilers.
there's most around us are going to be natural gas or propane, but there are
Okay.
oil boilers and there's steam boilers and I mean, so
Steam
that's
boilers. Wow. Damn, man.
the
This is a
source
huge
is sort of
field.
irrelevant. That's the other cool thing about hydronics is you can have several different sources. Like you can have an outdoor wood boiler and a
Wow.
gas boiler and an air to water heat pump all on the same loop delivering
It's blowing my mind right now. This is
whatever is the
crazy.
most efficient way for you that at that moment kind of deal, right?
Yeah.
Yeah, that's cool. Damn.
So I'm a real peel the onion back one layer at a time here. I want to go back to not the load, but one step further where let's say you got a load and let's say you've got a house that's got a mixture of different appliances. I'm trying to set the stage here for the discussion. Let's say we got a big living room, a big master suite, and we've got some bedrooms, like 3 bedrooms. And let's say the big living room is being handled by and the master's being handled by a ducted air handler. And let's say that we've got 3 bedrooms. 2 bedrooms have like those small, skinny base heater things. And let's just say one bedroom has like this. I know this isn't common and you probably ain't going to see it, but let's just say there's a cast iron radiator thing hanging out in the one bedroom. Obviously, that's not going to happen, but I'm trying to give like the lay of the land of the pieces, right?
So, I mean, you would then need to know the specs of each piece of equipment, right? And so then, so the way that these devices typically work is you have a certain flow rate through it, so water flow, and then a water temperature, and that tells you how many BTUs it delivers, right? And so you have to match those things up, and perhaps like uh, you can play with the output based off a different water temperature, right? So you may get one that is spec'd at a certain BTU if you use 180-degree water, but and so maybe it would be really oversized, but you're trying to size something for a lower water temperature. And so, and you're going to get less output based off a lower water temperature. And so the reason that water temperature matters is that the lower your return water temperature is, the higher efficiency you can achieve generally, right? Like, so it's the cooler we can keep our water, the easier it is to sort of maintain, right? Like we're not trying to create like this huge difference. It's sort of like compression ratio of a compressor, right?
Gotcha.
We want to keep that low.
Right. Right.
And so at any rate, like so you have to go back to like the specifications of the thing, right? And figure out your different water temperatures and flow rates and like you generally like group things into categories because you can have things that operate at different water temperatures, right? So you would then kind of group all your items that are similar water temperatures and choose a pump that can provide the amount of flow that you need and all your other devices, right? So you may have, let's say in this scenario, we have so many different things going on, we're probably going to have mixing valves of supplying different water temperatures to different things, right? And so I would
That sounds super complicated, bro.
How does one achieve different output temperatures from one boiler?
So your boiler would be targeting your highest water temperature, right? So let's say that your boiler is outputting 160 degrees, but at your air handler, you only want 120 degrees, right? So there is then different mixing strategies, but we'll just go with like a mixing valve because it's sort of the easiest to understand. It's sort of like it's a three-way valve oftentimes where you pipe your supply from your boiler that's 160 degrees, and then the return coming back on this loop tees into a valve that can sort of mix some of its return water with the supply, mixing, like targeting a specific temperature to that device. And so you may be flowing a certain amount in your 120 degree loop, but less through your 160 degree loop, if that makes sense, in order to
so
you're the water down.
You're
kind
saying
of like a shower valve.
Yeah.
You're saying that basically after you use hot water, let's just say in the baseboard heater that needs the highest temperature of water flow, before it comes back to go into the boiler, you're going to cycle that through a three-way valve into the air handler?
No, it's not really that. It uses so you look at things in separate loops. So your air handler would be a loop that it would only recycle that water that it used on that circuit, not necessarily one from a different circuit. You can technically you can pipe it the way that you are saying, but that's generally not the way that it's done. But you
see what you're saying.
You can do that where your return of a different device is the supply of another one, but you're not always guaranteed that the prior zone is calling, right? Like, so, you know, if that's the case, you're not actually getting that cooler water.
Yeah, no, it makes perfect sense now. You're saying the bypass loop has to be at the zone, controlled with the zone.
Correct.
Whatever that device is. You don't want to mix bypass cold flow from different zones.
Yeah, I mean, technically you can, and it just sort of depends, right? Like that's, but the easiest way to sort of visualize it and do it is with its own zone, right? And that's where it's however, there are other ways to accomplish it, and nothing's like better or worse than another.
What's commonly used today to operate that three-way valve? Is it a electronic three-way valve?
Yeah, they're generally all electronic valves. There are some that are a set temperature, but that's less
accurate,
desirable, right? Like you're not always, if you do the set temperature, you don't have as much control of what it's doing based off outdoor temperature, right? So generally the three-way valves there's two ways to do it typically, and one would be a set temperature, like we're discussing, and the other would be it would have its own outdoor reset, like I was talking before, that's independent of the boiler one, right? And so so it just sort of depends on where the overlap is with some of the other things, right? It gets technical in the weeds.
That's interesting, man. It's so what you're saying is you literally could size this thing. You could size any zone to whatever tonnage you want, really.
Well, you have to consider the cycle rate of the boiler. Right. And so you don't want your boiler banging on and off every second. When you're, and so it's not as simple as, it's sort of like what I would call micro zoning on a forced air system is bad, just like it is with hydronics, right? And and so there are ways to achieve it, but you can't just make like 50 square foot bathroom its own zone, right?
Yeah.
You know what I mean?
Right.
Do people do buffer tanks for these type, like in the chill water world, buffer tanks are common?
That's what you would do with smaller zones, or to handle cycle rates of a boiler would be a buffer tank. Now, but you also have to realize that the smaller your zone or load is compared to the output of your device, the bigger that buffer tank has to be, right?
Yeah, you got to have a
You
monster
can get
buffer
in
tank.
scenarios that you need several hundred gallons of a buffer tank to not be
Yeah,
cycling a boiler.
an unrealistic sized buffer tank that no one
Correct.
wants to buy or put in their home, right? Because
Yeah.
it's just way too big.
Yeah.
Got it. Yeah, that's it. I mean, do homes that have hydronics, do they typically have a buffer tank, or is that
No,
something you don't
typically not.
really? Okay, so sizing to the load is pretty important for hydronics. You
Well,
don't want it
so
really.
here's the thing. In the old days, cast iron boilers held more water, right? And so they sort of had
They're
their
like
own
their own.
buffer tank built in.
Yeah, right.
And so buffer tanks are more common in, newer systems and newer system designs, but it's rare to come to a home that, say, like in my area, most of the hydronic systems are pre 1950 or something like that,
Oh
or
wow.
Right.
60, right? So they're older systems generally, and those typically did not have buffer tanks in them.
Yeah.
What type of
So
controls are we looking at?
uh
I mean, there's different options, right? As far as older school ones would just be set a temperature, like the boiler just
Right.
maintains a temperature and you send it out to your distribution, whatever it is, whether
Right.
it's, cast iron radiators, whatever.
So I have a little experience in this because when I went to Colorado on a ski trip, I walked in at like midnight into a freezing cabin, and I was playing with the thermostat on the wall. Right, obviously, like no ducted unit; it was all just like baseboard heat through this thing,
Right.
which I knew nothing about. Right, I don't have that here, but I knew that when I seen it, I was like, okay, well, that's my heat. There's a thermostat. It just heats and radiates or whatever. And so, like, I'm playing with it and I turn it all the way to heat and I get down there and there's like no heat coming out. And I gave it like 5 minutes. Still, I'm like, no heat's coming out. I'm like, this ain't working. It's like midnight, got 3 kids. I'm like, they're not answering the phone. Like, we got, you had a punch code to get into this place. And I went straight at it, man. I ripped thermostat off the wall and there was 2 wires and I was like, well, this should be easy enough. I'm going to jump it out. And I did. I jumped it out and it freaking started working then. And I was like, okay. So to answer your question, Mike, I believe that it's strictly just a switch, right? It's a 2-wire switch controlling the individual zone heater. Now,
Cool.
I'm not sure.
Well, yeah, but then it's like, do you have a central pump or does it control a pump? Or so
Right.
there's different strategies here,
Yeah.
right? And so,
Right.
Yeah,
And then you have,
depends.
like you said, you brought up, there's also steam, and that's probably completely different.
Correct.
Well,
yeah, steam
Whew.
is a different animal.
Wow.
Yeah, I've missed there was actually one commercial building that actually had a steam boiler with gravity fed lines coming back from the cast iron radiators that we worked on
Wow.
quite a bit when I was in the game doing that.
Yeah.
So I learned a lot, man. I learned a lot
Cool
about
stuff.
steam.
Manhattan still does it. Manhattan has
Yeah.
heavy amount. I saw a documentary on it, and they do a lot of steam. I think
Yeah.
maybe in the Chrysler building. Cool
Yeah.
stuff, man.
Yeah, the Empire State Building
It's the
steam.
Empire.
Oh,
Okay.
like everything. Like there are the cool thing about I think about some of the New York areas and stuff is they actually have like central steam, like steam
Plants,
is
right?
delivered by the city or the municipality or whatever.
Yeah.
right?
Thank you,
what
bro.
I mean?
That's what I meant to
that's
say,
kind
because
of
it's
interesting.
so cool. It makes it look like Gotham City,
Yeah.
So
like you walk down the street, Chris, and you in winter, and you just get that steam coming out of like the floor, and you get that
Yeah.
feel,
So
It's New
you would
York,
probably you'd probably dig this, but down in New Orleans, Tulane has a huge centralized plants where they generate a lot of that stuff. Like for instance,
Oh, cool.
like clean water is sent from a plant where they recycle and clean their water and they send it in pipes to like Tulane University and up from the
Yeah.
ground. And we're talking way away from where the plant is. And I didn't
Wow.
know that till I went there and got a tour on it, and I was like, wow,
Yeah.
that's pretty wild. I never knew that was taking place down in the quarter.
You hear that, Flint, Michigan? You hear it? You hear that?
Yeah.
All
Steam
right.
is not my forte, I will say. Like, I know enough about it, and we do deal with some Steam where we're at, but
Yeah.
that's outside of the scope of what I know a whole lot about or whatever. I mean, I understand it and everything, but most of what I would work on would be
Right.
water-based
Now-
systems. And
Is the steam gonna kind of like slowly get phased out, kind of like oil, or is it just like something that's
well,
gonna
no,
be?
I mean, I'm sure there's certain things that it won't get phased out of easily or whatever, right? Like,
Yeah.
it's not always easy to retrofit steam, but
True.
but it takes a lot of energy to produce steam, right? And so that's the
Yeah.
downside to it, is that, and your efficiency is like your efficiency of the appliance, maybe not the system as a whole, right?
Right.
Like, but your system efficiency or appliance efficiency is sort of low because you got to produce steam, right? You
Right.
can't get into like super high efficiency style things.
Instead of warming something up, you got to really, really bring it to a high temp. Yeah.
Yeah.
Yeah,
That makes
I mean,
sense.
I've seen a lot of steam get put to use. I mean, medical facilities. Like I've worked on one that injects steam in the supply when they need to raise the relative humidity for like surgery rooms and things. So
Oh,
I don't
yeah.
think it's
Yeah.
and I don't
I
think
mean,
steam's going anywhere.
that's also where that's a little bit different than
Yeah.
using it for, but there's plenty of industrial processes and things that require it. Like
Yeah.
it's not going away for sure.
Yeah.
No.
I think Elon Musk is working on a steam powered car. No. It sounded better in my mind.
And you got to quit believing those ads on Facebook you scroll.
Yeah.
There are
Click here, Mike.
powered tractors.
Yeah.
And stuff like that,
Click on this link.
All right, Mike, I got one for you. Take me down the electrical road of how you would wire up the typical system. Let's go back to that scenario. We got 3 bedrooms. Let's just say the cast iron.
So what you have to know how you're zoning it, right? Like, and so let's assume that each zone sends a signal back to generally like a relay panel that then turns on a pump for that zone, right? And so, and then so essentially your thermostat for a certain area generally controls a pump or water flow. Sometimes they can control a valve, and you have one pump for everything, right? That just is nowadays they would generally be like variable speed, like trying to either maintain a pressure or maintain a certain temperature difference across 2 different things. And so and then it also sends a signal to your boiler that says, hey, I need heat, right? And your boiler then tries to target its output temperature.
So it's literally just like a chiller. I mean, that's exactly like what you described.
Yeah,
exactly
it's the same. It's just heat rather than cooling or whatever. I mean,
that's how we do it. I mean, there's a few different ways to do it now. It's but the longest played game that I've ever seen was, you start the pump based on a demand, you make water flow, you make a sales switch of some sort, and that'll fire up, the big boy to start producing cooling.
Yep. And but there may be different ways of doing it, but like at the end of the day, you have to have water flow. And so you may have different devices that you're signaling, right? So it's hard to speak like generally about it, but because like I said, you may be signaling a central pump that pumps everything, and then you're just opening a valve, or in other scenarios, you're signaling a pump and there'll be other pumps in the system potentially that are, controlling different things. Like
Gotcha.
oftentimes today, like the boiler will have its own pump that
Mhm.
ensures a certain flow through your boiler that may be different than what your zone is using, right? And so that's the thing that can trip you up about hydronics, is not always the same thing is occurring
Different
everywhere
piping.
in the system,
Yeah, there's different loops to it, right? It's like,
Correct.
um, I didn't know. I would. I guess it makes sense for a residential to be played game, the game to be played the same way as commercial. But that's how when I first learned commercial chill water, I learned about one pump pushing. It was the system pump, right? That would push water through the chiller. And then you would have the loop pump, which was sized to pump the loop, which would send water to all the air handlers. And then the system pump would just be tied to the loop, right? And what's kind of interesting is kind of when you walk in a mechanical room and you look at all that, you're thinking to yourself, how does the water know to flow in that direction? Right? Because it's just like connected, but it works. You know what I mean? But
Well, it's the spacing between it, right? Like, so if you move the spacing further apart, it won't work. The
oh,
spacing between the point it connects to the loop matters.
I did not know that. That's
Yeah.
fascinating. Okay, and because there's differential, right?
It's,
Because
yeah,
the pump.
so there's not, if so your T's and are close on there's not much difference between A and B. If you put a bunch of piping or stuff in between it, it doesn't work the same because you're because there's a bigger difference between A and B. You're not guaranteed to get flow going the same direction.
Okay.
And so where your chiller or boiler or whatever ties into your loop pump, or how
Yeah.
I get confused on what's the system pump and what's the,
Right.
like they call it primary and secondary in the boiler world or whatever, right? But at any rate, the if you I think it's generally like two times the distance of the size of the pipe, right? So if you got 1 inch pipe, it should be within 2 inches, or maybe it's four times the pipe. It should be within
Oh wow,
four
that
inches.
close.
Yeah.
Wow.
Wow, I didn't. Yeah, I had no idea that that was that critical. Because
And there's other things that it's just because the pumps interfere with each other. And so uh
hmm,
they call it hydraulic separation, right? So there's other devices you can use to do the hydraulic separation, right? Like you can also have a buffer tank in the middle where, like say your boiler loop is on one side and your system loop is on the other side, and that buffer separates the two, or allows you to have two different flow rates.
hmm.
Or what we were talking about is just closely spaced tees, is that when it's using closely spaced tees, they have to be spaced closely. So,
That's
Now,
wild,
are these
man.
all closed systems? They're not,
yeah, typically, I mean,
yeah.
and if you get, there are in commercial buildings or whatever, you'll have cooling towers, is what we would
Oh,
call them, or
right.
whatever, right?
Yeah.
That just use a
So I'll take that one a little bit, and I don't know that. Like, I guess I know the heating side for what I've done in the past, but it's like you have the open loop and you have a closed loop. And so, the open loops running the water exchange on the condenser side of the chiller, right? And it's going to the cooling tower, coming back to the condenser bundle in the chiller, and that's being handled. And they call that the open loop because it's going to an open cooling tower. Now, fun fact, you can buy another type of cooling tower and it's called something else, but there's actually a loop in the tower, and there's a heat exchanger in that
yeah.
tower where the water, that loop becomes closed at that point and it's not an open loop anymore. not very common around here. Typically, they're all open loops. Then the other loop we're talking about, what we were calling, I guess we're calling the secondary loop. We call it the closed loop, but the chill water loop that goes to all the devices, that's a closed loop.
Yeah.
And typically that you put chemicals in it one time, seal it, done, and it just loops, right?
Yeah, so the primary killer of all this stuff is air, right? So
Yeah.
open loops are harder to control and maintain, as well as, there's much more opportunity for things to plug things up or whatever. And, air also is what causes corrosion inside of piping systems and things, like, because a lot of the components are made out of iron or steel, and so managing air is important in hydronic systems. And so,
hey, just like POE oil, man. Oh, I had a doozy last week.
So is it common, Mike, is it common to, like, in the world that I've seen, those little, I think Honeywell made them, those little air bleed off valves that are like brass, and you pipe them in the top side of the piping of an air handler. Typically, in a really nice building, you might have seen them on every floor, but in like a building that didn't care so much, they would only put them on the air handler at the top floor. Do you see those in residential in what you're talking about? Like, how did they bleed the air
there's
off?
generally always some sort of air separation device, right? And there's different ways to manage it. What matters is that you get the air out. You don't necessarily have to have an automatic air vent system, although most systems do. But, theoretically, like, once you get the air out of the system and you're not having leaks, so you're not supplying new water, you're not magically getting air into the system, right?
Yeah.
And so, like, old timers around here would often shut the supply water off, or the makeup water, it's also called, to the system, in order to know whether you have leaks or not, right? Like, most of the time you have an automatic fill that's just trying to make sure that your loop is at, a certain pressure.
Right.
And it's typically like 12 to 15 psi or whatever. And so if that's on and you're constantly filling with water, that's where air can be introduced.
What the heck is black boiler water?
I don't know, but I like
black boiler water.
All right, Mike.
That's a tongue tie right there.
Here's a question for you, that one I don't know, that I've always wondered. This one's about expansion tanks. I'm assuming these systems that you're talking about have expansion tanks. How does one properly size an expansion tank?
Well, it's all based off the gallons that the system holds. And so it depends. You have to know how many radiators you have and how much piping and all that stuff. And so then, it's not, I can't tell you the formula off the top of my head or whatever, but it's based off the gallons that are in the system.
Right.
And so that's also why, several 100-gallon buffer tank means you're going to need a bigger expansion vessel or whatever, right? And so that's what it's all dependent upon, is how much piping and water volume as a whole is in the system.
But it's not going to hold all of the water, right? There's got to be some like equation that somebody has figured out.
You just are, the expansion is because the density of water changes at different temperatures, and you're just trying to account for that. Air does the same thing. It's just we're not like trapping it per se in a closed system or whatever.
It's the same expansion tank that we use for regular domestic electric resistant hot water heaters in Florida here.
Yes,
like a
Watts. The bladder will be at a different pressure, right?
Gotcha.
So you're but yeah, I mean, it's the same sort of thing.
Yeah,
And
so Chris, is just like a diaphragm. It's just, the pressure
Yeah.
gets up, just has a little bit of expansion. Yeah.
Yeah, I get it. I just never knew how to go about sizing one. Like I didn't
Housh
know.
has got it on a spreadsheet. You know it. Come on.
yeah,
Come
yeah.
on.
I mean, there is
After the
math
show.
that tells you how to do it based off, like, or how much a 3/4 piece of copper holds, and you've got 150 feet of it, or whatever, and
And what's your choice of pipe? PEX, copper, galvanized? If you had no money,
it all
wasn't an
depends
issue.
on what you're doing, and so there's limitations. PEX generally, most of the older systems would be copper, right?
Copper,
You'll use
right.
PEX if you're in doing radiant or air
That's right.
handlers, because your max water temperature of PEX is generally like 180 or something is what it's rated
That's
for.
it. Wow, yeah.
And so there are limitations. Steam is always going to be steel piping generally, and maybe copper as your returns or condensate in a steam system. But so it really just depends on the application.
Yeah.
And,
that's Chris's favorite slogan.
It is nice with another reason to keep your water temperature low is you can use PEX, and it's much easier to sort of run, even though it's harder to sort of make look decent compared to copper and things like that. But
it is nice for the floor, though. Like I see the guys get the nice loops in the floor. That's cool stuff.
That is, I have never seen that done in person. I would love to just go on a job.
It'd be fun,
bro.
Well, the thing
I just want to do one.
One time. That's
what I'm thinking about doing in my place is radiant ceilings or walls, because then you can play with radiant cooling.
Bro, radiant walls cooling?
Yeah, I think that would be fun.
Yeah, that would.
But radiant cooling, you have to obviously control. You have to know the dew point, right? So you have to control your water temperature to not be below the dew point.
Yeah, you can't make the sheetrock sweat. That's right. That's not fun.
Yeah, but
shoot,
it's but you want so putting in, like, the traditional radiant floor heat doesn't work well for cooling. Typically, and so you want to do walls or ceilings.
Oh, look at this!
Generally,
hey,
Mike, is it?
That's cool.
Is hydronics in the floor? Is that is it efficient to do that? I don't know the efficiency of like hydronic loops. Like, is that why do people jump?
It's mass, right? Like, so you have a battery sort of deal, right? Like, but the thing is, it's not. It takes. You can't change it quickly, right? Or expect it to change quickly. But
so if you get a spike,
you're out a lot of energy, and so it's easy to sort of maintain, and be comfortable. It's just, upfront cost is higher and things of that nature, but you have a large mass, right? So it is efficient. But it's just not, there's just other things to also be aware of there, right? And so you're in the scenario, like, sort of like, when you went to your Airbnb or whatever in Colorado or whatever, and like expecting something to move real quickly isn't the way that it works.
Right. So the floor type one is not going to respond quickly, but if you have, it complements well for a home though, like warm floors and then air system. I mean, that's cool.
The beauty of radiant heat is it heats the surfaces and things around you, right? I mean, in the building science world, we know about mean radiant temperature and all of that stuff, right? And so you're controlling that and doing it differently than you are through other mediums.
And it's nice. Like when you're walking through a house, you got socks on and the
Well,
floor's
I think
warm.
there's challenges though, and that's where like I currently in my last remodel or whatever, I'm actually not connecting back about 80 to 90% of my radiators, and I'm trying to use forced air because I still want to filter my air and move air anyways.
Right. Yeah,
and
you want to filter
I've
the
done
air.
that in
Yeah.
the past, so I'm really trying to see how my system operates and does with a hydronic air handler.
So would it be safe to say that radiant floors are kind of like a dehumidifier in like the cooling aspect, like it's almost like a complementary thing, like in the cooling world,
Yeah,
like,
well, I mean, I would say it's I don't know if that's the greatest analogy. I don't know that I have a good one per se, but like it's not.
It won't take care of your whole heating load like an emergency.
No,
like,
it can absolutely take care of your whole heating load and everything. It's just there's different ways to do it, and there's different trade-offs that you have to be aware of. And like for me, I still think that we should move air in a home. Even if we are using some form of radiant, right? And so it's like, what trade-offs are you willing to make and do?
Right. But it's not, it can't take care of, like, you can't have a house all it has is radiant and then that's it.
Well, I think it depends on if you're only talking heating or not, right? Like
that's what I mean. Yeah.
Then it's a different ball game, right? I mean, like you would not be able to do in my climate or any of our climates, at least, you wouldn't be able to do full like radiant cooling and expect it to not. You would have to have dedicated dehumidification in the equation somewhere. Right.
That's some cool stuff, man.
It's fascinating.
It's really cool because I don't get any of this, Mike. So I really appreciate you talking.
This is
two Southern. I don't get to either. One Southern and one Southern Yankee. Yeah.
A question I have about design, like this, it's not a design question, I guess, but it kind of is. You talked about the central plant, like the boiler or having a wood-fired boiler. You could optimize which one you want to run and tie them in. How does that get piped to work in tandem? Like, I guess let me
that's where you take go back to your chiller loop pump and system pump, or primary, secondary, however you say it, right? Like, so it would be in line or in the part where your boiler is and has nothing to do with your infrastructure or how you're distributing that to places.
So my secondary heating plant device would be ran in parallel with the first primary heating device. Like, if it does did I say that right?
Yeah, they would be in the same loop as that. And so it's just like, which one are you sending water through or not? So what's supplying your hot water to your system loop?
What do people like? Does each one, I guess this could differ, but you could probably make one pump run both, right? And have isolation valves, but is that
or three-way valves or some way, but you would, so like, there's just lots of different ways to do it, right? Like, say you were doing an air to water heat pump, you would probably go, through the air to water heat pump or something first, and then through a natural gas boiler after that to boost it if you need to for like a dual fuel system or something, right? Like, so there's lots of different ways to do it, but that is it. I think the way to look about it and think about it is like what you're supplying or your distribution system to your home is like independent of what is feeding that its water temperature, right? And so that's where you can have multiple devices on this other side of it that are working to supply that water. Like what you're doing inside your house doesn't care. It just needs a certain water input to it, kind of thing.
So I don't want to. How do I say this? I know this is going to eat up quite a bit of time. Maybe it won't. I don't know. But I got a hammer down question. Oh, go ahead. Yeah, make that shout out happen.
Dude, the Housh is a system. Everybody needs to jump on that group.
Yeah, if you're not there, you should be following Housh. That's Housh's Facebook group. The Housh is a system. There's nothing this man doesn't know. Just go ahead and say it.
These two guys did a video a long time ago, but I want to know how the Franken system is doing.
Good. I mean, that's
good. All right.
Yeah, I mean, I finally got the hot water hooked up to it recently, so I'm playing with that now and trying to figure out. Like currently, it's short cycling like crazy in heating, so my water temperature is too high, obviously. But I don't have it all running on my outdoor reset yet. So I just sort of chose a water temperature of like 120 degrees right now, and that's too hot for the temperatures we've been having. And
is that too hot? Is that too hot because you have other plans to run more water to other things from the boiler and you just haven't tied it in yet?
Correct. Yeah. So I currently have.
How'd you know that, Chris?
Because he's like I have 120.
I have 120 is low loops too, and it's the challenge I have is like which one is running the most or how to sort of balance that out, right? So now I'm sort of trying to choose in the middle of the two to sort of see how it all
Mike,
works.
This is a no judgment zone because we know you work on everybody else's ACs and heating, so it's the same here, man. My unit is still a busted mess, but
but before the thing is, without hooking up the Franken system, the hydronic air handler, it didn't make sense for me to change boilers, right? Like, because I couldn't run my other one at a low enough water temperature with all the baseboards that I had before, right? Like it was, I literally tried for several years of running it at a really low temperature, which would have actually killed my boiler, but it was like 40 years old to begin with, so I didn't care. But it wasn't.
And we all, for all the people that don't know,
output, and so I had to like crank the water temperature up to where I'm not getting efficiency, and so it's like this double-edged sword of like then having to get all my other stuff in place to be able to actually put in a high efficiency boiler.
Yeah. It's cool to watch the whole process, man.
I have a question for you, and I'm trying to figure out how I propose this question. I'm going to give it a shot. If
say yes, Mike.
If someone is interested in this and they want to do it, man, how do you learn how to do if I wanted to put hydronics in my home, I could do a load calculation, yes.
Okay.
But where would I go and what software would I get to know how to lay it all out there? So so something could tell me this system holds this much water. You need a buffer tank this size. You need how do I plug all the pieces into an equation?
Is there like a hydronics group, like a Brian Orr symposium for hydronics?
So what I would recommend is Modern Hydronic Heating, which is a book by John Siegenthaler. He also writes a lot of articles for like Kalefi has a thing called Hydronics.
Beat me to it, Chris.
So you get into, there are software packages, but I don't know exactly what they're called because I don't use them. I do all the math manually or whatever, but Modern Hydronic Heating is my Bible for all of that.
Cool.
When I need formulas and figuring everything out, Taco or Taco, the pump manufacturer, has a lot of good information. Bell and Gossett is another manufacturer that has a lot of information, and so you basically learn through documents and things.
Right.
Dan Houlihan, the pumping away is huge. Everybody loves that. But
Nice.
for me personally, like I said, the modern hydronic heating is my Bible. That has all the formulas in it. That's my reference when I go back and I need to know something.
Right.
That's what I'm looking at.
That's cool. I feel like hydronics gets a lot of plumbers. It's like a little, you know,
It depends on the area of country you're in, right? Like, so there's, I know in the Northeast a lot, like plumbers do boilers. Around here, plumbers wouldn't know at all what to do. Like, they could supply water to it, but aside from that, they don't know what the heck they're doing with boilers, right? Like, so it sort of depends on what part of the country you're in, I think.
And here, I'd say here, like, typically the big boilers, and I'm talking about the ones that, you know, fit in a whole freaking room. Like those, they're specifically boiler, you know, mechanics. Like
so
they're boiler mechanics.
In my state, if it's over 200,000 BTUs, you have to have a different certification to work on it, right?
Okay.
And everything, right? And so that's why, like, a lot of tankless water heaters and things are designed at 199,000 BTUs, because in a lot of states or whatever, there are regulations of, you know, different mechanics and stuff have to work, or you have to have different certifications above a certain BTU an hour in hydronic systems.
Okay, guys. So,
wow,
that's a lot. It's a lot. So here's how I want to polish off the show, Mike. I want you to give me, let's just say, the top three things you don't ever do on a hydronic system. Like, what do you not do?
Put your tongue on the pipe, right?
Let's see. You don't cap off a pressure relief valve or disable a pressure relief valve. You don't jump out high limit switches. And let's see. Like, you don't have too low of water temperature if you don't have a condensing boiler.
Whoa. Oh, I got the first two on lockdown.
Yeah.
I understand the problems
The third
that come
one,
from that. Expand on that third one for me. Say that again. If you have...
So if condensation in a boiler is dictated off of water temperature, right? And so you don't want to run a standard efficiency boiler at too low of a water temperature, or it creates condensation and rusts the thing out.
That's over my head, but I'm going to take it.
That's awesome, man. Dude, what a show, bro. What a show.
Like, don't be a jamoke and cap off a pressure relief valve, all right?
Yeah, absolutely. Dude. All right, guys. I mean, what else could you ask for? That was a hammer down show, Mike.
Thanks, bro. I really appreciate that, man.
Thanks for having me. I appreciated it.
See you guys next week.
Catch you on the next one.
See ya.